Design patterns represent the best practices used by experienced object-oriented software developers. Design patterns are solutions to general problems that software developers faced during software development. These solutions were obtained by trial and error by numerous software developers over quite a substantial period of time. I'm Balaji Chandrasekharan. Today, I will be discussing about the basic overview of the design patterns. Design patterns have two main usages in software development. Common platform for developers. Design patterns provide a standard terminology and are specific to particular scenario. For example, a singleton design pattern signifies use of single object, so all developers familiar with single design pattern will make use of single object and they can tell each other that program is following a singleton pattern. Best practices. Design patterns have been evolved over a long period of time and they provide best solutions to certain problems faced during software development. Learning these patterns helps unexperienced developers to learn software design in an easy and faster way. Gangs of 4 Design Patterns is the collection of 23 design patterns from the book Design Patterns, Elements of Reusable Object-Oriented Software. This book was first published in 1994 and it's one of the most popular books to learn design patterns. The book was authored by Eric Gamma, Richard Helm, Ralph Johnson, and John V. Lisides. It got nicknamed as Gangs of 4 Design Patterns because of 4 authors and then shortened as GOF Design Patterns. The Gang of 4, GOF, design patterns are categorized into 3 main types: creational patterns, structural patterns, and behavioral patterns. These categories help in understanding the patterns based on their purposes and uses. Creational patterns focus on the mechanisms of object creation. They aim to abstract the instantiation process, making a system independent of how its objects are created, composed, and represented. Abstract factory pattern provides an interface for creating families of related or dependent objects without specifying their concrete classes. Builder pattern separates the construction of a complex object from its representation, allowing the same construction process to create different representations. Factory method pattern defines an interface for creating an object but lets subclasses alter the type of objects that will be created. Prototype pattern specifies the kinds of objects to create using a prototypical instance and creates new objects by copying this prototype. Singleton pattern ensures a class has only one instance and provides a global point of access to it. Structural patterns deal with object composition or the organization of classes and objects to form larger structures. Adapter pattern allows incompatible interfaces to work together by converting the interface of a class into another interface clients expect. Bridge pattern decouples an abstraction from its implementation, allowing them to vary independently. Composite pattern composes objects into tree structures to represent part-whole hierarchies, letting clients treat individual objects and compositions uniformly. Decorator pattern attaches additional responsibilities to an object dynamically, providing a flexible alternative to subclassing for extending functionality. Facade pattern provides a unified interface to a set of interfaces in a subsystem, making the subsystem easier to use. Flyweight pattern reduces the cost of creating and managing a large number of similar objects by sharing objects in a fine-grained manner. Proxy pattern provides a surrogate or placeholder for another object to control access to it. Behavioral patterns are concerned with algorithms and the assignment of responsibilities between objects. They describe not just patterns of objects or classes but also the patterns of communication between them. Chain of responsibility pattern passes a request along a chain of handlers, allowing multiple objects a chance to handle the request. Common pattern encapsulates a request as an object, thereby allowing for parameterization of clients with queues, requests, and operations. Interpreter pattern, given a language, defines a representation for its grammar along with an interpreter that uses the representation to interpret sentences in the language. Iterator pattern provides a way to access the elements of an aggregate object sequentially without exposing its underlying representation. Mediator pattern defines an object that encapsulates how a set of objects interact, promoting loose coupling by keeping objects from referring to each other explicitly. Memento pattern captures and externalizes an object's internal state without violating encapsulation, so the object can be restored to the state later. Observer pattern defines a one-to-many dependency between objects so that when one object changes state, all its dependents are notified and updated automatically. State pattern allows an object to alter its behavior when its internal state changes, appearing to change its class. Strategy pattern defines a family of algorithms, encapsulates each one, and makes them interchangeable, allowing the algorithm to vary independently from clients that use it. Template method pattern defines the skeleton of an algorithm in a method, deferring some steps to subclasses, allowing them to redefine certain steps without changing the algorithm structure. Visitor pattern represents an operation to be performed on the elements of an object structure, allowing you to define a new operation without changing the classes of the elements on which it operates. These patterns are widely used in software engineering to solve common design problems and improve code maintainability, reusability, and flexibility. We have reached the conclusion of the session and look forward to seeing you in our next one. We hope you have enjoyed the video. Don't forget to like, share, and subscribe. Thank you for tuning in.